Hi everyone, welcome to this video about linear regression. Linear regression is used to predict the value of a variable based on the value of another variable. The variable to be predicted is called the dependent variable, or what we call outcome variable. The variable to be used to predict the other variable's value is called the independent variable, or the predictor variable. For example, you could use linear regression to understand whether exam performance can be predicted based on review time. Sales can be predicted based on advertising cost. Here are the assumptions for our data before we can use linear regression. The two variables should be measured at the continuous level. Here are examples of data in interval or ratio level. Second assumption, the relationship should be linear between the two variables. So it can be positive, it can be negative linear relationship, and this one is not linear. Third, there should be no significant outliers. And fourth, there should be independence of observations. Fifth assumption, the data needs to show homoscedasticity, which is where the variances along the line of best fit remain similar as you move along the line, just like this third scatter plot here. Sixth assumption, the residuals of the regression line are approximately normally distributed. Let us assume that all those assumptions are satisfied by our sample data here. So let's start with the sample results problem. A business analyst wants to find out if advertising cost is related to sales for a period of 10 months. He also wants to use this information to estimate the amount of sales in the succeeding months where advertising cost is known. For our statement of the problem, what regression model will statistically significantly predicts the outcome variable? In our results, it's sales. Let's have this as our example. Sample data. So we have the 10 months here, and then we have the advertising cost for each of the months and the corresponding sales. We're going to predict our sales if the company will spend spend 55,000 for advertisement. Okay, so we're going to use SPSS to actually find the regression equation. So we have to actually organize our data in this form in Microsoft Excel, or it can be also in SPSS. So we just copy this data here. No need to copy the 11th. Then you have to paste it in our SPSS. Make sure that it's in the data view. So click on the first cell, you right click it, and then you paste the data. We're going to change the variable name. So click variable view here. And then the first one is actually advertising cost. Okay, and the second one is actually our sales. That's for the variable name. We need to change the measures. So advertisement cost is actually scale. That's a ratio level. Sales is also scale. Okay, so that's it. We already inputted our data in our SPSS, and if you actually watch the video on person R, we found out that there is actually a significant relationship between these two variables, and from that we can actually use this data to predict, okay, sales based from a given advertisement cost. So we can proceed to linear regression if there is actually a significant relationship between the two variables. So to find the regression equation, we need to follow these steps. Okay, so you have to click Analyze, and then you go to Regression, and then you choose here Linear. Okay, for our dependent, we have to input here our dependent variable. That's our outcome variable. So in this study, it's sales. So click on sales, and then you click this arrow here for the dependent variable. And our independent variable is actually advertisement or advertising cost. So click this arrow here for the independent variable. And that's it for this dialog box. You may actually click OK for the output. So we have here the output for our data. Okay, so now we're going to continue that with our PowerPoint. So here are our output. The first one is a model summary. So in this table, it provides the R and the R squared values. The R value represents the simple correlation, and in this case, R is equal to 0.882, which indicates a high degree of correlation. If you square that value, 0.0882, it becomes 0.778. And this indicates how much of the total variation in the dependent variable, the sales, can be explained by the independent variable, advertising cost. In this case, 77.8% can be explained, which is actually large. Okay, this R squared is called coefficient of determination. The other table is the ANOVA table, wherein this table indicates that the regression model predicts the dependent variable significantly well. Why? Because of this value of the P here, which is 0.001, less than 0.05. Okay? The third table is on coefficients. So the coefficients table provides us with the necessary information to predict sales from advertising costs, as well as determine whether advertising cost contributes statistically significantly to the model. So the B coefficient tells us how many units of sales increases for a single unit increase in advertising costs. So these are the B coefficients. This is the constant, and this is the B for advertisement cost. And it says here in the P values here, both are less than 0.05 level. So the two are significant. To make the regression model, or what we call the equation, it should be in the form y is equal to a plus bx. So it's just a linear function or linear equation. In this case, in our problem or in our example, the y is what we call the outcome variable. That's the dependent variable, and that's actually the sales. A here is the constant, and the value of that is this number here, 106,173, okay, 0.811. And then we have actually our B here. This is the B, the value of B here for advertisement cost, that's 6.457. And then X here is our independent variable, the predictor variable. So that is the advertising cost. Okay? And the next thing is how to interpret these values here. So the high adjusted R squared, that's actually our 77.8%, okay? tells us that the model does a great job in predicting sales. On top of that, the B coefficients are statistically significant with the values of P here 0.036 and 0.001. And this number 6.457 means that for every unit increase in advertising cost, a 6.457 unit increase in sales is predicted. So, to answer the question a while ago, what will be the predicted sales if the company or business spent 55,000 pesos in advertisement? So you will just do substitution in our regression equation. So our advertising cost is 55,000 and you multiply that with 6.457 and you add it to our constant, the total sales will be 461,308 pesos. So that will be the predicted sales for the 11th month. We can also show the best line of fit or what we call the regression line for our equation using our SPSS. And this is actually the output of SPSS if you get the graph of our regression equation. And that's all for our linear regression. This is Roldan. Diyos mabalo. See you in my next video. God bless you. Bye.